All right, today we're going to start using or introducing some other tools to help us factor a polynomial that's greater than degree 2. And we're going to talk about something called the rational root theorem. And what this does is gives us a starting point. It gives us some numbers to start trying out in a polynomial. Because if I just give you the polynomial without any binomial to divide into, we need to figure out, well, what are the potential roots that are going to work? So we're going to start first with defining the rational root theorem. So here's the start of the rational root theorem. If a polynomial function p of x has integer coefficients and an integer constant, then every rational root of p of x is of the form p over q. P over q. So we create a rational root from two numbers in the polynomial. So p, the numerator of this little ratio, is going to be a factor of the constant term. That's the number without the coefficient, the number at the end of the polynomial. And q is a factor of the leading coefficient. That's the coefficient of the highest degree term. So it's the first coefficient when you put the function in standard form. So the best way to really explain this is to show you in an example. Again, and we're just trying to find a list of possible roots for a polynomial function. Alright, so here's what we're going to do. We're going to use the rational root theorem to determine the possible roots of p of x. So we're just going to create a list of possible roots. They won't all work, but we're just going to generate a list. So here's my function. I have 2x cubed plus x squared minus 13x plus 6. It's in standard form. I have my constant term, and I have my leading coefficient. So the possible roots are going to be the factors, the combination of any factors of 6, because that's the constant term, over the factors of 2. So here's how we do this. Each factor could also be positive or negative. So we're going to list out the factors of 6. That's going to be little p. And the factors of 6 can be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All of those. It's any whole number that divides into 6 is basically what we're doing. So that's all my potential numerators. I have 8 possible numerators to create some of these roots. And then we're going to find the factors of 2. That's for my denominator. Plus or minus 1, plus or minus 2. That's every whole number that divides into 2. So then what we have to do is create a ratio, all the possible different ratios between these numerators and these denominators. Well, and we'll just keep the plus minus with every one so we don't have to write all the positives and then all the negatives. If I take each numerator and put it over plus or minus 1, I just basically get all of these values again. So possible roots, I'm going to write them out here. The possible roots start with plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That's what you get when you take each one of these and you divide it by 1, positive or negative. And then what we have to do is take each one of these and divide it by positive or negative 2. We're not going to repeat anything that shows up again. So for example, 2 divided by 2 is already represented. 6 divided by 2 is already represented, but I have 2 that are not. And one of them is 1/2, and the other one's going to be 3/2. So those are my other 2 possible roots, plus or minus 1/2 and plus or minus 3/2. The rational root theorem says that any rational root from this polynomial function can only come from this list. So this gives us a starting point when all I give you is a polynomial function and I say, find all the roots. Alright, so now we're going to take this same example, because I already found all the potential rational roots, and we're just going to find all the roots. And we're going to draw out the factors using synthetic division. So we just used the rational root theorem to list out our possibilities. Now what you do is a trial and error process. You start choosing these potential roots and you use synthetic division and start dividing them out. How do you know if you get one that works? You're going to get a remainder of 0. So this is trial and error. You got to be careful with your calculations, because if you mess up a calculation, you'll skip over a root and you'll be doing an awful lot of work for yourself. So let's not do that. Synthetic division. We're going to, it's already in standard form. It's a third degree, so I should have 4 numbers. I'm going to put down the 2, the 1, the negative 13, and the 6. There's my coefficients. And I'm just going to start by using a positive 1 as a root. So we do the synthetic division process. I bring the 2 all the way down, I multiply it by 1, and I add, and I multiply it by 1, and I add, and no, that one isn't going to work. So I know that positive 1 is not a root. 1 is not. That doesn't mean negative 1 doesn't work, but I know that positive 1 does not work. Let's try positive 2. So we do this again. We write down our coefficients, and 6, and put this box in here, and I bring the 2 down. 2 times 2 is 4, 5, 10, negative 3, negative 6. This one works. Yay, it works. That means that 2 is a root. So that's cool. We got one of them done. So here's what we're going to do next. I need to go to a clean sheet, but I'm going to take this and write it as a factor, and this is going to be these are the coefficients of my depressed polynomial. So I'm going to write that out next and see where we are. Alright, by using the rational root theorem and synthetic division, I was able to draw out a factor of a third degree polynomial. So that's kind of cool. When I'm down to a second degree polynomial, we know from here we can either factor it or use the quadratic formula to find the final 2 roots. This one happens to be factorable, so P of x can be represented by, I have my binomial that works, and now I'm going to separate the 2x squared into 2x and an x. I got to put a 3 in there such that when I take their difference I create a 5. That means 3's got to go here with a positive and a minus 1. Because if you check your inners and outers, you're going to get 6x minus x, which gives you the positive 5x. So now my polynomial is all factored, and I can find the roots. X minus 2 is equal to 0, so we know that x equals 2 is a root. 2x minus 1 is equal to 0, so x is going to be 1/2. And then x plus 3 is equal to 0, so x is going to be negative 3. If you go back to your original list, you'll see that all of these were listed when we did the rational root theorem. So this is the process we're going to use in class, and we'll practice it quite a bit more to figure out the possible roots of a polynomial function that's greater than degree 2.